All right, so next up we're here going to talk about transformations. So for transformations, you can see here there's a lot of rules, and so we got to read through these, but I'm going to kind of give a big piece of advice to start. And so I'm going to put that up here, and that is this. So inside the function is always horizontal change. And it's also the opposite of what you would think. It's just kind of opposite land in there. And so we see that a couple of places here. So it says f of x minus h. So subtracting inside, you would think if it's horizontal change, subtraction would move it to the left, but it actually moves it to the right. Conversely, if we have the f of x plus h, you would think that that moves it to the right, but it actually moves it to the left, okay? So that's what I mean. Just got to kind of keep that in mind, that this is opposite of what you would think, okay? All right, so we see that actually again here. And so I'll highlight this as well. So when you have multiplying going on inside of the function, and so we see that right here, b times x inside the function. So if there's a big number multiplying in there, such as this, b is greater than 1, you would think that multiplying by a big number would make it bigger. It would stretch it, but it actually shrinks it. So this is going to shrink it horizontally. And then once again, conversely, if the number is between 0 and 1, so like 0.5 or 1/2 or 1/3, you would think that multiplying by a fraction is going to shrink it, but it's actually going to stretch it. So kind of like I said there, okay, so just keep that in mind, that inside the function is opposite land, if you will, and so everything is kind of not what it seems. Now, outside the function is going to be vertical change. And this one is actually same as what you think. Okay, so we see that a couple of places. So we see here we have if we have a number adding outside of the function, like that k right there, you would think that if it's vertical change, adding is going to move it up, and it does. It moves it up. So once again, this one is actually the logical one. It's the inside that's illogical. So we have here f of x minus k. You would think that that moves it down, and it does. It moves it downward k units. This also goes for the stretches and shrinks. So if we have a number multiplying in front of the function, if that number is greater than 1, that is going to be a stretch. And so that, once again, is logical. If you multiply by a big number, it's going to get bigger. It's going to stretch. And then, once again, conversely, if you multiply by a small number, like a fraction, it's going to be vertically shrunk, okay? And then the last thing we have to keep in mind here is our reflections. So this is kind of its own category here, the reflections. So if it is a negative outside, that is a vertical reflection. So keep that. It actually does still follow my rule here of outside the function affects vertical change. But they call this a reflection about the x-axis. Now, if you're thinking, hey, how is it vertical if it's across the x-axis? Well, think about kind of what happens here. I'll draw my little coordinate plane here. If you have a point and you're moving it across, if you are up here, if you go across the x-axis, that moves it down there. And so that is an x-axis reflection with the negative f of x, okay? So if the negative is on the inside, that's going to be a horizontal reflection, but they call that a reflection about the y-axis. So if you had f of negative x, it would go over there. All right, last thing here is the even and odd functions down at the bottom. We're going to get to those later. All right, so our first one here, we're going to describe our transformations. And so we always kind of do these in PEMDAS order, and so I'm going to reference back up to our notes there. And so PEMDAS, we would do the inside the parentheses first, so I would take care of the x plus 2. And so remember that inside the function is horizontal change. So this is going to be a shift to the left by 2. So if it was minus in there, it would have been to the right. If it's plus, it's going to go to the left. Next thing I'm going to deal with is the negative multiplier out front. I do kind of think of that as a multiplier here. So I'll go ahead and do that in the yellow here, since that's how I did it in the notes. And so the negative out front is the x-axis reflection. It is a vertical reflection, remember, but we describe it here as an x-axis reflection. And then last thing we got is the -4 out back, and so that is outside the function, and so that's going to affect vertical change. It's going to be either up or down, and in this case, since it is negative, it's going to be down 4. Remember that is the logical way for it to go, because it is negative, and outside the function is more logical. All right, so next up we'll look at number 2. So for this one, we're going to start on the inside. Now, there's actually kind of two things on the inside. So we got to look at the 2 and the negative as separately, okay? And it kind of mentions that right here, if you read this part. So let's see what we got here. So I'm actually going to start off with the 2 right there. Okay, and so multiplying 2 on the inside. Now, so multipliers are either stretches or shrinks. So you would think that a 2 being greater than 1 would be a stretch, but remember, that means that this is a horizontal shrink. And then it says here by a factor of 1 over b. So I'll say here by a factor of 1 over 2. So we go 1 over whatever that number is. Okay, so then next up here, we'll deal with the negative separately. And so the negative in there, remember, is the other reflection. So that's going to be a y-axis reflection, which will be a horizontal reflection. All right, so then we'll keep going here. So we have a 3 multiplying out front. Now, multipliers outside are vertical stretches or shrinks. But since this number is greater than 1 and we're outside, it's going to be a vertical stretch by a factor of 3. And then finally, we have the +1 out back, and so that is going to be a shift up 1. So once again, it's outside the function, so it's going to be an up or down shift. And so it'll be in the same way that we think. Next up here, I'm actually going to jump down to numbers 6 and 7 here. So, and then we'll go up and do numbers 4 and 5, because I think it'll be a little bit easier that way. So for number 6 and 7, so given the function f of x, we need to write the new formula if we have kind of this other stuff going on, okay? So we're going to start off here with the cube root of x, and so that's going to be like our parent function here. And we're just going to apply this, the shifted 4 units to the right, and then we're going to apply the shifted down 3 units, okay? So we'll build our parent function here, like I said, is our the cube root of x, okay? And then to shift it 2 units to the right, we know we have to subtract 4 on the inside. And then to shift it 3 units down, we know we have to subtract 3 on the outside. And then they just told us to label this as g of x, and so I'll say g of x out here equals. So you can see we took care of those 2 transformations, 4 units to the right, and then 3 units down. So same idea here on the next one. So we have absolute value graph. So our absolute value graph is going to be our parent function. And so I'll do the absolute value of x here. And then it says first it's going to be compressed. So that's like saying it's going to be shrunk by a factor, vertically shrunk by a factor of 1/3. So that means multiply by 1/3 out front. And then it says shifted 2 units to the left. And so that means I'm going to add 2 inside. Remember, that's the opposite of what you would think. And then lastly, we want to go up 6 units. So that's going to be a +6. Okay. Oh, and then we'll label it g of x. All right, great. So same idea here with number 4 and 5, except we have to kind of be familiar with our parent functions. We have to identify which parent functions these are. And so for this one, for number 4, I would say the parent function is x to the 3rd. Remember, x to the 3rd is that like little squiggly guy here that goes like this. And so you can see that looks like that, but I can definitely see it does have some transformations. So first of all, it looks like it's gone to the right. I'd say like the center of this graph is right here. And so we have a right 2 shift. We also have an up 1 shift. And then we also have a reflection, because you can see it's kind of going from high to low instead of low to high. So I'm going to call this one a vertical reflection. So I'm going to say it's an x-axis reflection. This one's a little tricky because it could actually be either one. So I'm just going to call it an x-axis reflection though. And so we're going to go ahead and write our function then. So I'm going to say, since we went to the right 2, I need to go x plus 2 in parentheses before I go to the third power. And so that's putting that plus 2 on the... Oh, I messed that up. Sorry. I did it the same way you would think. No, it's opposite you would think. It would be x minus 2 to the third power to move it to the right. Excuse me. All right, and then we have to move it up 1, so we're going to add 1 on the outside. And we have to do our x-axis reflection, so that's going to be a negative out front of that. So that's going to be my new function here. G of x equals, and then I got my 3 transformations there, the reflection with the negative out front, the x minus 2 on the inside of the cubed, and then the plus 1. Next one over here, this one looks to me like it's our absolute value graph. And so our absolute value graph, remember, is the v, and it goes up 1 over 1 on each side. And so I see a couple transformations here. It looks like it went right 1. It looks like it went down by 3. But then I also notice that it looks like there's a vertical stretch here. So the vertical stretch, I can see that because instead of going over 1 and up 1, this one goes over 1 and up 2 on each side. So I'm going to say that that's a vertical stretch by 2. So I'm going to label my function now g of x equals. And then we're going to have our absolute value in here. But I have to move it to the right 1. So I'm going to go minus 1 inside the absolute value. And then for the down 3, we're going to subtract 3. And then we'll vertically stretch it by 2 by multiplying by 2. All right, this one is asking us to describe the transformations given a function. So it's kind of very similar to one we did with the f of x, except now it does a specific function like x squared. And so I see here the plus 7 is inside, and so that's going to be a shift to the left by 7. Now we would think that it would shift right if it adds, but remember that's like opposite land in there. And then the minus 1 out back is going to be up or down, so let's shift down 1. All right, so then next up, number 9 here. So we have x minus 3 inside. So it's inside the square root, so that's going to be our left-right shift. Once again, opposite of what you would think, so that's going to be right 3. And then, let's see, we have, we're multiplying by 2 here. So, let's see. Oh yeah, the multiplying by 2, that's going to be a vertical stretch. Remember, if we have a fraction multiplying out front, that's a vertical shrink. A number greater than 1 would be a vertical stretch by a factor of 2. All right, and then we have a plus 5 out here, so that's going to be our shift up 5. Okay, cool. All right, so then next up here, we have a graph. So this is kind of like a made-up function here. And so they're saying to apply these transformations. So the plus 2 we know means shift left 2. And then we also then have the negative out front, and so that is an x-axis reflection. So I kind of do this on these ones. I just do it point by point. And so on each one of these points, I'm going to shift it to the left 2 and then flip it across the x-axis. So the x-axis is right here. So I'll just start over here at this point. So I'll first move it left, 1, 2. And the reason I'm doing that first is kind of PEMDAS order here. So we'll do the inside of the parentheses first. So I'm going to go left 2. So it'll go left 1, 2. And then it's going to reflect across the x-axis. So it's going to go up here on the other side of this. So it was 2 below. Now it's going to go 2 above. So there is going to be my new point it's going to be right there. So I moved it left 2 from here, 1, 2, and then reflected it across the x-axis. All right, so same thing for this point. I'm going to move it left 1, 2, and then we're going to reflect it across the x-axis. So it's going to go down there on the other side. It was 2 above. Now it's going to be 2 below, right here. All right, now our next point here, same thing. Over 1, 2, shift left 2, and then reflect across the x-axis. And so that's going to put that point right there. All right, and then the last one here, we got this one right here is going to move it left 1, 2. And then it's going to reflect across the x-axis. Now this one was only 1 away from the x-axis, so now it's going to be 1 away on the other side. And so now I'll just connect these, and so there is my graph. All right, next up here, we're going to describe the transformations and then sketch the graph. So first of all, I'll just run through these. So we have our +1 on the inside, so we know that's a shift left 1. And then we have a multiplying 4 out front, so that is a vertical stretch by a factor of 4. And then we have our -5 out back, so it's a shift down 5. Okay, so next up, to graph this, I have to kind of be familiar with the parent function here. So I see that we have a squared up here, and so that tells me that this is the parent function of y = x squared. If you kind of think back to our parent function chart. And so we know that that one is a parabola. It's got its center at 0, 0, and then up 1 over 1 on either side. And so for this one, I'm first going to shift the center of that graph, or the vertex as we usually call that. It's going to go left 1 and down 5. And so that's going to move it down here. Left 1 and down 5 would be right here. So that's going to be our vertex. And then where I'm going to take into account the vertical stretch is on the next 2 points. So usually it's over 1, up 1. But instead of that, it's going to be over 1 and up 4. And so you can see that that makes it kind of a lot taller here, which is how the vertical stretch is supposed to look. So you can kind of compare that. If I would have drawn this parent function here, it would have been kind of like this, so a lot wider. Okay, next up, we'll do number 12. So we actually have 4 transformations here. We have a shift right 2, and then we have, that's a shift. All right, and then we have the 3 out front, so that's going to be another vertical stretch by a factor of 3. And then we also have a negative out front, so that's going to be an x-axis reflection. And then we have the +1 out back, and so that's going to be a shift up 1. Okay, so once again, we need to think back to our parent function here. So this one, since it's a square root, I would say it's just y = the square root of x. And so that one, it starts at 0, 0, and then up 1 over 1, and then it's like half of a parabola on its side. So first of all, I'm going to shift the center there, the starting point, right 2 and up 1. So that's going to go right here. And then our next point is where we're going to see the we're going to see the stretch and the x-axis reflection. So instead of going up 1 over 1, I'm going to go down 3 over 1. So I kind of think of that -3 as kind of like the slope, but it's not the slope of, like, it's not a line, obviously, but it's the slope from the first point to the second point. And so that's going to go down like this. And so you can see that's like a lot taller than our original parent function, and it's kind of upside down, which is the x-axis reflection. All right, last up here, we're going to talk about even, odd, or neither. And so here, we'll do our definitions for this were on the first page, but I'm going to go ahead and rewrite them here. So the definition for even is that f of negative x equals f of x, okay? So if I plug in a negative x, I'm going to get the same thing as if I plug out a positive x. Now, the definition for odd is that if I plug in a negative x, I get the opposite of that. So everything has been changed. I have a negative in front of that. So I'll check out number 13 here. So for this one, if I did f of negative x, I get negative x squared. Oops, it's going to be plus negative x. Okay, now I know that negative x squared is actually x squared because squaring turns everything positive, but I know this one's turning into negative x. So, is it the exact same as it was before? No. Is it the exact opposite of as what it was before? No, because this one's the same and this one's different. So if that happens, that's going to be a neither. All right, so the number 14 here, I'll plug in f of negative x here. And so if we have negative x to the fourth, minus negative x squared, well, I know that a negative x to the fourth power turns everything positive, and the second power turns everything positive too. So if I did my, just in parentheses, negative x squared, that would turn into positive x squared, and then this minus is just carrying over. So this is actually equal to the equivalent, or to the original, because the even exponents turn that positive, and so that's going to make this even. All right, and then lastly, we'll do number 15. I'll do it down here. So for this one, if I go f of negative x, it would be negative x to the third plus a negative x. And this is going to turn into, well, the third power actually keeps things the same sign as they were, so that's going to stay negative, and that one's going to turn positive. And so this one is actually the exact opposite of what it was before, and so this one is odd. So you may have noticed something interesting here, and it seems even more obvious than the way we did it. If all of the exponents are even, that is going to be an even. And if all the exponents are odd, that's going to be an odd. And if you have a mixture of each, that is going to be neither. That's not the only definition of it, but with exponents, that is a good shortcut.